Hello and welcome to this video segment. My name is Ryan Manwood and today I'll be presenting on the topic of control charts. So my objectives for this video is to enlighten you on what control charts are, how they are useful, how do we know if a process is in control, and finally we'll conclude with an example of creating a C chart. So what are control charts? A control chart is a graph used to study how a process changes over time. Common examples are P charts, C charts, X bar charts, and R charts. Every control chart has a center line, an upper control limit, and a lower control limit, as we see here. So how are control charts useful to us? They help us to monitor how a process changes over time, help us to reveal the stability or variability in a process, and it can help us to distinguish between random and assignable variations. Random variations are those which occur in every system and are outside of our control. Assignable variations are those special causes which we can't control. So the general idea is that control charts help us to determine whether a particular process is in control. So how do we know if a process is in control? When looking at a control chart, we see that the process is in control if there are no points above or below the upper and lower control limits, the points are randomly distributed, there is no distinct trend in the plot, the variability of the process is constant over time, and there are no sudden jumps in the data values. Notice in this diagram here, this is an example of a process which is in control because it satisfies each one of these criteria. Now let's look at some examples of processes which are not in control. So if you look at this process here, we have 2 points, one above the upper control limit and one below the lower control limit, and they are outside of the limits. So this process is not particularly in control. More examples of out of control processes can be seen here. Whenever we have a trend, as here, upward trend, downward trend, if we have an upward shift pattern, a sudden jump in the data value as we have here, we have a downward shift pattern, a sudden downward jump in the data pattern as we have here, a systematic pattern, a cyclical pattern. All these are examples of processes which are possibly not in control. Now let's consider an example of creating a C chart. So before we actually jump into our example on C charts, I just want to iterate some points on C charts. C chart is used to measure the number of non-conformers in a process. By non-conformers, we mean such things as defects or even customer complaints. So here we have our example on the creation of the C chart. It says that the local manager at a department store has recorded the number of customer complaints each week for the past 10 weeks. And he has asked you to develop a C chart using the following data. So here we have the number of complaints, and here we have the corresponding weeks. Notice our sample size here is 10, since it was collected over a period of 10 weeks. So in order to create your C chart, you need to know some formulae, and here they are. The center line, C bar, is nothing more than the average of our C's. So we would, in this case, in the number of complaints, that represents C, we add these up and divide by 10 since we have 10 samples to get the average, and our upper and lower control limits are given by these formulas. So here we've calculated our center line and upper and lower control limits. Our center line is the average of our C values, so our C here, when we total these, this gives 96. It was collected over 10 samples, so that's 96 divided by 10, that's 9.6. Similarly, our upper and lower control limits, plug those into our formula, and we get 18.9 and 0.3 respectively.
Okay, so I just want to make one little point about these decimal values that we found for the C chart. Now, for the C chart, since we're talking about the number of, in this case, the number of complaints, some textbooks will state that you cannot have decimal values for your complaints, but there are some textbooks which would leave it as decimal. So in this video, I am leaving them as decimals, but if your instructor wishes that you round them, you should.
Now it's time to graph our C chart. So you will use suitable scaling for your axes. I've done this in Excel. And the first thing you want to do is just plot your LCL, UCL, and centerline. So here we have our LCL at 0.3, our centerline at 9.6, and our upper control limit at 18.9. Next, we want to plot our points. So how you plot your points on the graph is like this. For week 1, we had 4 complaints. So you look on your graph here, in week 1, we had 4 complaints, you put that point there. In week 2, we had 6 complaints. So week 2, 6 complaints, put that point there. And you continue along in this same fashion, and you should end up with this scatter of points as I have here. Next step is to connect those points with a smooth line graph as I have here. You should end up with a graph looking like this. Then you want to analyze the control chart whether or not the process is in control. So here I've superimposed a trend line, this red trend line here, and you can see that this is representing the number of complaints, and we can see that the number of complaints over time is increasing at this local department store, and so we would say that this process is not in control. Therefore, the manager needs to take corrective action to find out why customers are frequently complaining about the products and services. So in this video, we learned what control charts are, what they are used for, how can we use them to tell whether processes are in control, and we saw an example of how to create a C chart. So I hope this video was helpful to you. Thanks for watching.